Hello everyone, I am Bireshwar Roy. I have completed my bachelor's degree in physics honors in 2017 from Ramakrishna Mission Vidya Mandir Belur Math. I was the gold medalist in my batch. Then I cracked IIT JAM examination and secured All India rank 19th. I went to IIT Kanpur for pursuing my master's degree in physics. I completed my master's degree in physics in 2019 with Academic Excellence Award. Then I joined Indian Institute of Science, Bangalore for pursuing my research work. Apart from my research work, I was actively involved in the teaching activities since last 3.5 years. In the last year, I was working with NPTEL team as a GATE physics tutor. I taught almost 100 students. Also, I was giving online private tuition to 4 of my students for IIT JEE Mains and Advanced Examination. One of my students secured 715th rank in JEE Mains 2023. So today we'll be discussing about the chapter Electrostatics. In this chapter, I'll be covering these topics. First, I will give the brief introduction. Then I will talk about the electrostatic force and Coulomb's law. And then I will discuss one problem regarding this Coulomb's law. So let us start. So what does it mean by electrostatics? So electrostatics is the field in physics where we deal with the interaction between two or more than two charges, where the charges should be stationary or statics in space. That is why we named it as electrostatics. Now let us consider a system of charges. System of point charges in space, and they are fixed at their position. We'll name it as Q1, Q2, Q3 and so on up to Qn. So there are n number of charges in this system. We'll call these as source charges. Now we'll consider another charge fixed in the space, that is Q. We'll name it as test charge. So here the position of the Q charge with respect to ith charge in this system is given by Ri. Now the fundamental question asked in the chapter, that is electrostatics, is what type of interaction will be there in between these two charges. So basically the question is what will be the force acting on Q due to Qi. So here Qi is the system of discharge where I runs from 1 to n. So answer to this question is given by the concept of electrostatics. So this solution to this problem is facilitated by the principle of superposition. So what does it mean? If we want to compute the force exerted by this system of charges on this test charge Q, so first we'll compute the individual force due to Q1, Q2, Q3 on Q charges. Then we'll add the forces vectorially. So we have to take the vector sum of the individual forces. And when we will be computing the force between, electrostatic force between two charges, it will be unaffected by the presence of other charges in the space. So mathematically we can write the force acting on Q is given by F1 plus F2 plus Fi up to Fn. So here Fi is the ith charge that is Qi, exerting force on Q, and this is the total electrostatic force. So in short form we can write it as summation over Fi, where I goes from 1 to n. So this is basically the superposition principle. Now the next question comes, what are the factors upon which this force, electrostatic force, will depend? So there are basically mainly three factors which will affect this electrostatic force between two charges. So factors affecting FQ. First, it will depend on the two charges under consideration, that is Qy and Q, both on the magnitude and sign. So how will it depend on the sign of the charges? So if the charges are similar kind, that is either plus plus or minus minus, then it will be, the nature of the force will be repulsive. If charges are dissimilar kind, then it will be like plus minus or minus plus. This, for this combination, will have attractive electrostatic force. Second factor is the distance between Q and Qi. And third factor that will affect the magnitude of the force, electrostatic force, that will be dielectric constant of the surrounding medium. So now we will discuss about the electrostatic force and Coulomb's law. So in 1785, scientist Coulomb has proposed the Coulomb's law, which basically gives us the idea about the interaction between two stationary point charges. Suppose we have two charges QA and QB. Our origin is here. So with respect to this origin, the position of the QA charge is RA, and with respect to the origin, the position of the QB charge is RB. So what will be the position of QB with respect to QA? That will be this, and it is given by R vector equals to RB minus RA. So the Coulomb's law states that the electrostatic force between these two charges, that is F, will be proportional to the product of these two charges, that is QA times QB. Also it is proportional to 1 by R square, where R is the distance between these two charges. So as it is inversely proportional to R square, so it is also known as inverse square law. Also we can see here, if the two charges are either positive or negative, then this quantity will be positive, so force will be repulsive in nature. If the two charges are dissimilar kind, that is one is positive and another is negative, then it will have a minus sign here, so the forces will be attractive sign. So we can write F equals to 1 by 4 pi epsilon naught epsilon r times QA QB by R square. And as force is a vector quantity, so it will have certain direction and it will be along r cap direction. Here r cap is along this direction, so along the r vector, and r cap is the unit vector along r vector. So we can define the r cap vector like this. It is r vector divided by modulus of the r vector. So here r vector is already we have defined, that is rb minus ra in our case. So from here we can see the force is dependent on the product of these two charges as well as the distance between two charges. Now one important thing here, before that we will discuss about this constant, that is 1 by 4 pi epsilon naught epsilon r. Here epsilon r is the dielectric constant of surrounding medium and epsilon naught is the free space permittivity. Its value is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter. In our problems, we usually use this term 1 by 4 pi epsilon naught. It is easy to remember, this value is 9 into 10 to the power 9 and the unit will be Newton meter per Coulomb square. So one more important thing here, if we just plot this electrostatic force between two charges as a function of r, so it is inversely proportional to r square, so the plot will be like this. Now one question comes, is there any limit on the r that is the distance between two charges below which this Coulomb's law breaks down? Yes, there is some limit. We'll denote it as r naught. So below r naught, the Coulomb's law, the nature of the Coulomb's law will not be valid here. So the typical, so below r less than, so r less than r naught, Coulomb's law will not be valid. Here the order of r naught is around 10 to the power minus 15 meter, which is 1 femtometer. So this is the limitation of Coulomb's law, which has been observed experimentally. Now one more important point in Coulomb's law we'll discuss now. So we have two charges QA and QB. We are considering both the charges as positive charges. So the force, nature of the force will be repulsive. So with respect to QA, the position of QB is along this, that is r vector, and the unit vector along this r vector is r cap. Now the force due to this QA charge on QB charge is, the force on B due to A will be 1 by 4 pi epsilon naught QA QB divided by r square, and force will be repulsive in nature, so it will be along this direction, so it will be r cap. Now if we talk about the force acting on this charge QA due to QB, we can write it using the Coulomb's law, that is FAB equals to 1 by 4 pi epsilon naught QA QB divided by r square. Now the force will be along this direction. So we have considered this direction as r cap direction, so we will write it as minus r cap. So we will give it as 1, it is 2. Now what is the relation between these two forces? We can write it as FBA equals to minus FAB. So the conclusion is the magnitude of the force in both the cases are same, but directions are totally opposite to others. So actually an important conclusion can be made from here. It is consistent with Newton's third law. So according to Newton's third law of motion, every action has its equal and opposite reaction. So if we consider this as action, then this force FAB will be reaction, or vice versa. So Coulomb's law is consistent with the Newton's third law of motion. Now we'll discuss an example on the topic Coulomb's law. Let us consider this problem. We have x-axis. On this x-axis, 2 point charges are there at the position x equals to a and x equals to mu a. The charges are q and lambda q. Here q is greater than 0. And here mu and lambda constant. Also one more condition is given here, that is q plus lambda q is also constant. So total charge in the system is constant. Now we have to find the condition on lambda for which the electrostatic force or the Coulomb force between these two charges are maximum. So question is, what is the condition on lambda such that the electrostatic force is maximum? So for this problem we will simply use the Coulomb's law. So what we can write, first we are given this total charge here is constant. So we will denote it as q, which is a constant quantity. So we can write q equals to q minus lambda q. Now according to Coulomb's law, the electrostatic force on either q or q. So I am considering the electrostatic force on lambda q, that is F is 1 by 4 pi epsilon naught q times lambda q divided by the distance is mu a minus a. So mu a minus a whole square. And the direction will be, if we consider the force on lambda q, so it will be along x direction. So it will be along this direction. We are considering both the charges are positive. Now we are given that we have to find the condition on lambda for such that the electrostatic force is maximum. So magnitude of this force will be maximum. So for that, what we will do, we will take the differentiation df, that is df d lambda, and at the maximum this quantity should be 0. So we can write d lambda 1 by 4 pi epsilon naught q lambda q divided by mu a minus a whole square equals to 0. So one thing we can do here, we can just substitute this q from the equation 1 here. So we can write d lambda of 1 by 4 pi epsilon naught q minus lambda q times lambda q divided by mu a minus a whole square. That should be 0. Now this quantity and this quantity is constant, so we can take it out from the differentiation. dd lambda. Also we are multiplying these two terms, so lambda q minus lambda squared q squared equals to 0. From here, so this cannot be 0, so only the thing is dd lambda of this term will be 0, so we'll take the differentiation of this, so we'll get from here q, that is capital Q and small q, 2 lambda small q square equals to 0. We'll take the q as common, so q times capital Q minus 2 lambda q should be 0. As q is greater than 0, that is not equal to 0, so only this term should be 0, so we have q equals to 2 lambda q. So we can write here q equals to q by 2 lambda. We are getting this expression. Now we'll put this expression in the, so we'll can call it is as 2, putting 2 in 1, what we'll get, so q by 2 lambda equals to q minus lambda times q by 2, lambda times 2 by q by 2 lambda. So lambda will cancel out here, so we'll get q by 2 lambda as q by 2, q will cancel out, 2 will cancel out, so we are getting lambda equals to 1. So if the lambda is equals to 1, then the electrostatic force acting between these two charges will be maximum. So this is the answer for our question. Thank you.